Here we have this question. Curve is given by y equal to this fraction. Find the y, the x. And second one, find equations of the normal to the curve at x equal to 1. Okay, let's see the solution. Step 1, do the algebra. That will be equal to what? Y equal to what? Over 2 squared, that's 4. And then x to the power 3 squared, that's what? Minus this one also over this. That's a 4x to the power 5 all over 4x to the power 6. So that's the algebra. So this means this one over this one minus this one over this one. That's the algebra. This we cancel, so we have 2. This is a square root. Remove the square root. That will be x to the power half minus 6 minus 4. We cancel each other. So we have what? X to the power 5 minus 6. The bases are the same and you are dividing, you apply indices. The bases are the same here and here and you are dividing, you apply indices. Okay? So we then have now 2 half minus 6. That will give us what? X to the power minus 11 over 2. Then minus what? X to the power what? Minus 1. 5 minus 6. That's minus 1. So that is y. Then we can now do the what? Go to the y, the x. So all these are preliminary. So these are the first thing we have to do, which I call the algebra before we do the y, the x. Okay, so this will become 2 times minus 11 over 2. The power will go to the front. Then this expression, minus 11 over 2 minus 1. Okay, here also, the power here will come to the front. That's plus. Minus 1 times minus become plus. Then we have x what? Minus 1 minus 1, that's minus 2. So this and this we cancel. So we have minus 11, so x to the power. If you do this one, minus 11 minus 1, that's a minus 13 over 2. And then you can do this one, that's plus 1 over what? 1 over x squared. Okay? So that's the differential coefficients, which we call the y the x. So if you like, you can remove this minus here. But the y, the x will be equal to minus 11 over x to the power what? X to the power 13 over 2 plus 1 over x squared. Okay, so that's that in that. Then the second part, we are told to find the equation of the normal to the curve at x equal to 1. So if x equal to 1, we need to complete the coordinates x, y. So when x is equal to 1, let's get the y. So y will be equal to what? Square root of 1 is 1. Okay, so on the numerator we have 8 minus 4. And then here, that will be 2 times 1 cube. That's a 2 squared. That's what? That's 4. So we have 1. So the coordinate is what? 1, 1. Then we need to find the gradient. The gradient is what we got in here. But let's get the gradient at the point at x equal to 1. X equal to 1 is going to give us what? Minus 11. This is 1 to power. 1 to power, any power is 1. So plus. This is 1 over 1. So the gradient is what? Minus what? Minus 10. So that's the first thing we need to do before we can get the normal. So then we now find the gradient of the normal, which is a perpendicular to this. So the gradient of the normal will be what? Minus 1 over what you have here, minus 10. That's equal to what? 1 over 10. So that's the gradient of the normal. So using the equation of a straight line, which is you can use this one. I have this, okay, I can get my c, I know this one also. So y is equal to 1, okay, my gradient of the normal is 1 over 10, okay, times what? Times 1 plus what? Plus c, okay. Can you multiply all through by 10? So this will be 10, this is also times 10, that's 1 plus what? 10c, okay. Move this one to the other side, we have 9 equal to what? 10c. So c is what? 9 over 10. Okay, so on the final note, the equation of normal is y equal to, my n is what? 1 over 10 times this, and then plus what? 9 over 10. That's my equation of normal. And that's finished that question. Please quickly smash the watermarks on the video and subscribe. Turn on your notification so you can get notified anytime there's a new updates. Share the links of this video. Click on like button. Thank you for doing that. The B part of this question, we have A curve is given by this equation. Find the coordinates of the stationary points and determine their nature. So what we're going to do for us to find the coordinates of the stationary points is for us to get the y and the x, the derivative. And let's do that without wasting time. The y, the x will be equal to, we differentiate the constant, that's 0. Then differentiate this one, we have minus 120, okay? Then this one, the power here, times this one, minus 84, x, the power also minus 1. Then this one, 3 times 4, that's minus what? Minus 12, x squared. At the stationary points, your dy, the x is equal to what? Is equal to 0. So in that case now, we're going to have minus 120, minus 84, x minus 12, x squared equals to what? Equal to 0. We can do the arrangements according to the power, and that will be minus 12, x squared, minus 84, x minus 120. So we can divide all through by minus 12, x squared, then plus 7x, and then plus 10. Okay, then factorize that, pair this x squared. Factors of 10, that's a 5 and 2, that can give us a plus 7. That will be plus 5, and then plus 1, plus 2. So in that case now, this is equal to 0, this is equal to 0. So we have x is equal to what? Minus 5 or minus 2. So the stationary points are what? Minus 5 and minus 2. So these are the stationary points. Then the next thing to do now is to determine the nature, okay? And if you want to determine the nature of the curve, it's very simple. We are going to do the second differential of this equation, whereby we've already gotten the first differential. Okay, so the second differential is for us to differentiate this one again. That will be minus 24x. When x is minus 5, substitute into this equation and get the y value. So if you do that, when x is minus 5, y is what? 74. Also, when x is what? When x is minus 2, y is what? Do the same thing also, substitute there. That's 128. Okay? Therefore, let's continue here. Second differentiate at x equal to minus 2. Let's get the value. Plug in that. That minus 64 plus what? Plus 48. Okay? Do your subtraction. That will give us minus 36, which is what? Which is less 0. So the meaning of this is that when your second differential at that particular point is negative, is less 0, then we can conclude and make a minus 2, that point, comma what? When x is minus 2, y is what? 128. So this is what? This is a minimum what? This is a minimum point. Then also, the second differential at x equal to minus 5. Let's do that also. That will be equal to what? Minus 84. Okay. That's minus times 24 times minus 5. That's a plus 24 times 5. This will give you positive. That's 36, which is greater than what? Greater than 0. Okay? So we can make a conclusion that that point, minus 5, when x is minus 5, y is what? 74. This point is a maximum point. That point is a maximum point. When your second differential at that particular point, when it's positive, when it's greater than 0, that point is what? Is a maximum point. So that is the nature of the curve. Okay? At this point, quickly smash the watermark on the video and subscribe. Okay? Click on like button, turn on notification so as to get notified anytime there's a new update. Thank you for that.